In Premium, I showed you how forms help you draw from imagination. In this and the next free episode, you'll learn how architects and designers plan forms before they build them. A piece of paper is pretty simple. It's flat. A three-dimensional object is pretty complex. It's not flat. So how do we plan this complex object on a simple, flat surface? Well, we could show it directly from the front, like this. But from the front, we can't know that the body is this long. And from the side, we can't know that the wings aren't this long. Also, the front and side views don't tell us the shape of the wings. We need another view for that. Whatever the object, if we want to create three-quarter views, we need information from more than one straight-on view. Straight-on views are called orthos. We'll take 2 of these free lessons to understand them. You've heard of 1, 2, and 3-point perspective? Orthos are 0-point perspective, like a map. The point is to get the object out of perspective into the most direct view possible to show how this thing looks from front, side, and top, or even other angles. Orthos typically show any of 6 straight-on views: left-right, top-bottom, front-back. That was easy. I don't even need to repeat it, but I will. We'll call them side, either side, front, maybe back, top, maybe bottom, side, front, top. That'll do. From 0 to 1. Here's a straight-on front view of a skill you love. From the side or the top, we can't read it. But that doesn't mean we can't show more than the front and make it look 3D. Watch. Put a point back there. Run lines from the corners, and it goes to the far distant shore of infinity. That's 1-point perspective. The top view would go on forever. So let's end infinity here. With a mindset to figure, you can deduce every edge by repeating the shapes of the letters, and that's still 1-point perspective. If you want an assignment, that's going to be one. Do it with something you care about. We'll come back to this. 1-point wonders. Let's take a minute with a famous perspective example, the railroad track. Looking straight down on those tracks, the rails don't meet. Yet, when they go away from our eyes, they connect, probably at the horizon line. If they're level on the ground, that is where they'll meet. Not in the air, not in the earth, on the horizon. That's convergence, one way we make a flat surface look deep. But not every line on here converges. These left to right lines don't have vanishing points, and neither do up and down lines, because they don't tilt away from our face like the rails do. They do, however, diminish in height and in width, because they get distant. That's diminution, another way we make a surface look deep. But this is about lines that travel away like the rails of a track in 1-point perspective, which is how it appears when you stand on the tracks, which you shouldn't. Okay. Left-right, no vanishing points. Up-down, no vanishing points. Close-far, 1 vanishing point, just 1, and that affects everything else. In 1 point, height and width lines diminish as depth lines converge. 1 point is simple, but that doesn't mean that it's anything less than amazing. 1 point can make space look deep, or quite flat, depending on how you use it. 1 amazing point. 1 amazing point. Back to the issue. As soon as we see something tilt into space, it isn't an ortho anymore. It's an oblique view. In this case, it's 1 point perspective, the easiest kind, so we start here.
1 point is all you need to look 3D.
Now, your assignment. Draw your name into deep space. You'll feel monumental. Make sure you spell it right. This is extruding a flat front plane. It is simple but involved.
In Premium, I'll demo to address what can go wrong and point you right. Also, we have more in Premium I think you'll like. But let me remind you, if you want to draw in perspective, these free lessons will give you all that you need if you do the assignments. If you want more, Premium is there at proko.com/perspective.
In a coming lesson, we'll see what happens when we step off the tracks, add extra points, and carry through with how paper and space relate. In the meantime, play with 1 point.
1 amazing point. 1 amazing point. 1 point is all you need to look 3D.